Hey, how's it going? It's Miss N here. So if you're watching this, it's because 1, maybe you just need some review of what we did in class. 2, you've been gone or absent. Or 3, again, you just want to catch up on some things and not fall behind. So whatever the reason is, again, you can stop the video at any time. This is just me trying to put Key Concept 3 into a series of videos to help anyone out that needs some extra practice. So I'm going to start with this beginning section. Again, this was just the introduction to systems of equations. So first of all, what is a system of equations? Okay, again, if you're taking notes in your notebook or just taking them right on this sheet, again, either way works fine. Okay, so a system of equations, again, it's just going to be multiple equations that we're working with at once. So we're used to graphing an equation of a line or just one equation at a time. Again, we're going to be working with this system now, so it's going to be 2 or more equations we're working with at one time. So again, you're not just going to be graphing one thing, you're going to be graphing 2 or more at a time. Again, I have to write with my finger here, so bear with me. Again, I'll try to write as neat as I possibly can, but if you can't read something, please let me know. Again, just in general, a system of equations is working with multiple equations at a time. We're just going to be working with 2. We won't be doing any more than that. Okay, so let's look at 3 situations. Again, we talked about when something has no solution, one solution, or infinitely many, when we were working with just one equation at a time with one variable. Okay, now we're going to talk about what this looks like in a system. So first of all, again, see if you can remember from geometry what kind of lines these are. And again, you can pause yourself to think about it because I will just go ahead and start filling it in. So these are parallel lines. Okay, so these first set are a set of parallel lines. If you remember, parallel lines are going to run side by side. Again, this was the mark used for parallel lines. They're never going to touch. So this system will never have a solution. So it's going to have no solution. Again, I don't know why it's tabbing up like that when I write it, but again, the system is going to have no solution. Okay, they're going to have the same, let's see if I can move that up here. Let's go here. Perfect. So it's going to have the same slope. I have no idea why it's writing like that. Give me 2 seconds. I'm going to try to fix that because that's going to get annoying. Okay, they're going to have the same slope. Let me go like this. Interesting. Okay, so they have the same slope, so that's what you'll want to fill in here, and a different y-intercept. Okay, these are parallel lines. Again, it's just going to be shifted up or down, so they'll have the same slope, the pattern of graphing is the same, but they start at a different spot. Okay, let's move on to these set of lines, the second one. Okay, so that was no solution for the parallel ones. These, you can say 2 different things. You can say they're crossing or you can say they're intersecting. I'm going to stick with intersecting. Again, just work with me here. In the next video, I'll try to do it in OneNote. Maybe the tabbing won't happen like that. Okay, so they're intersecting lines. Okay, and these are going to have one solution. Exactly where you see them crossing is where you're going to have that one solution. Okay, and these have different everything. We won't look at a lot of cases where they have different slope and same y-intercept. So let's just focus on the cases where they have, again, a different slope and a different y-intercept. Again, it's 2 completely different equations, so they'll end up intersecting at some point. Okay, so they'll have different slope, different y-intercept. Now this third case, again, I always just put a star next to it because I think it's honestly, I think it's the weirdest, but the coolest case at the same time. I don't know if I love it or hate it. Okay, so again, it's a set of lines that are overlapping. So if you look at the graph, okay, it literally looks like there's one equation there. Okay, but there are actually 2 equations graphed. So pretend the equation here was x minus 2 or something. it's going to be just that same line graphed twice. That's how you get a system that's overlapping. And this type of system will have an infinite amount of solutions. Okay, if you think about like stacking two lines right on top of each other, like if I have a line here and I put another one right on top of it, it's literally the same exact line. They're crossing in all places possible. So they have the same everything. Like I said, it's just two equations that are the same. I don't know why it's writing like that. Again, it's the same slope and the same y-intercept. That looks so messy, sorry. Again, I have no clue why it's tabbing down like that. But again, it's the same exact slope and the same exact y-intercept. Okay, so these are the different three cases we'll see with graphing, and that's the first method I'm going to teach you in the next video, and I can almost guarantee it will be your favorite. Okay, so again, if you want to rewatch this or stop at any point, again, we have three cases. Parallel lines, no solution. Intersecting lines, one solution. And overlapping line, infinite solutions. Okay, once you feel like you're okay with this and you're like, yeah, I think I could start some questions, go ahead and move on to the first method of solving, which is graphing.